Hi, welcome to NashFP. This is the Nashville meetup for functional programmers. We meet the fourth Tuesday of every month right here at Emma, just by downtown Nashville. And you can find us online at nashfp.org or on Twitter at nashfp. So I'm gonna start by, tonight we're gonna talk about SQL, of all things, and we're gonna talk about like how, what the relationship is between SQL queries and functional programming. And if I can share my screen, then we'll get started. All right, that's the hallway of doom. That means it's working. If you hear any explosions tonight, I guess there's just an event downtown that has a cannon, and they have the cannon, they're going to use it. So I don't know. Just ignore that if you can. So can y'all read that? That's actually like really kind of strange. I'm going to mess with the video a little bit. I don't know what to mess with. Do you have any suggestions? It's kind of tiny. That's not much better. All right, well. Nope, okay. Yeah, the projector, like if I plug directly into the projector, it doesn't work. So we're just kind of stuck with this, and I'll just make this as big as I can make it. Can I make that? Okay, that'll go away, great. Okay. All right, cool. So I have some sample queries. So first of all, who in this room has used SQL before and has written select statements? Anybody? Literally everyone. Great. Okay, good. That's one thing I don't have to explain. But I do have to see if I can. All right. So who in this room knows JavaScript? Almost everybody. Okay, great. All right. Okay, so we're going to be using JavaScript for this, and if let's switch branches real quick. No big deal. Okay. All right. So I want to show you the code that I've got so far. I have a sample database that I just dumped into a bunch of CSV files. There's one CSV file per table, and I'll just go ahead and show you that right now. This is actually in a repository that you can find if you go to github.com/nashfp/rdbms. That's a relational database, blah, 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 right? And if you look in that repository under the tests/select directory, there are a bunch of these markdown files, and each one has one query, and like, what is the answer we expect back from the query from the sample database? And the sample database is located in this other directory, under the, this other directory, where it's just a bunch of CSV files, right? One per table. And this is the Chinook database. This is somebody at Microsoft needed a sample database, and they just generated this. And it's tiny. Like if you look at these files, each one is a couple kilobytes in size. So if I just look at the customer table, you know what CSV is. It's comma separated values. Each line of code on each line here is not a line of code. It's just a line of values separated by commas. And there's a total of like 59 in this database, right? So it's a tiny database. But what we also have is a copy of this database in SQLite format. So I encourage you to get this repository if you can. Like go to github.com/nashfp, grab it, download this, and inside the repository you will find a database that you can query yourself and you can follow along. So I can just show you what this looks like. There is a program called SQLite. If you don't have it, you can probably install it with one command on your system. I know on Mac you can just reinstall SQLite, and you'll get this. And you can just give it a file name of a SQLite database, and boom, you're in a mode where you can query that database. And SQLite is just basically a disk-based SQL engine. There's no server component or anything to it. It's for embedding in other programs, right? It's a database without all the heavyweight server stuff, right? So if I want to show the CSV file that I was just looking at, the customer table, I can just do select star from customer, and it gives me all that data out, okay? So what I would love to do tonight, I don't think we'll get this far, but I would love to do this. I would love to tonight implement code in some language so that we can get that far. We can actually write this stuff in the functional language of our choice, and you can type in a select statement, hit enter, and it'll actually run. That'd be really cool. Right now, I just want to show kind of. I want us to think real hard about what a select statement is, what it means, and see what the parts are and how they work together, right? So I want to take real select statements and kind of boil them down to what would that look like in code, all right? So where was I? Sample queries, great. All right. So what I've got so far is this is code that runs in Node.js, which is just like JavaScript you can run the command line on your computer. And I wrote a little function. I found some Node modules. One of them is a CSV parser, so it reads CSV files off your disk. That's convenient, and every language has this. And I found another one that will take two lists and give you all combinations of those two lists. And we're going to use that later on. We haven't. We'll get to it when we get to it. Here, I wrote this little function that all it does is it just calls the functions that are built into Node or into this, and the one that's built into the CSV library that I found. And all it does is just find a table on disk, read it into memory, and return a list of lists, right, or an array of arrays, which is what a table is, right? And then I loaded a bunch of the tables off disk. So if I run this right now, it'll do nothing. But if I have it dump a table, I actually have not tried this, so I guess we'll see what happens. Hope this worked. Yeah, all right. So it just dumps. So the CSV library reads reads the CSV stuff into memory and turns it into objects. So it's not an array of arrays. I lied. It's an array of objects, and it gets those property names from the first row of the file. It's pretty basic. But we're going to use these objects. We're going to use these 5 arrays that I just loaded into memory right here. And we're going to use those to implement the code for a handful of select statements. All right? And you guys are going to do it for me. I'm not going to do anything up here except what you tell me to type. All right? So first example is this one. All right? And all these examples, I've got them also in this separate directory that's full of examples. It's got 20 or so. And that's kind of just a test set of select statements that you can use tonight if you decide to go that route. But I'm going to start with just this one. Select name from genre where genre ID equals 6. And again, if I dump that table out, I can actually just show you the table. Tables. This is the table, right? It's a very, very simple table. It's just got 2 columns. Okay, so what do I need to type in order to print the name that corresponds to genre ID 6? What can I do? So I I guess the kind of the point that I'm going to try and get to tonight here is that select statements are a functional construct. They are they're like an Elixir pipeline. You feed data in one end and you do some stuff to it, and out comes the answer you want. So what do you think?
Well, you do a filter of some sort.
Okay, cool. Does anybody know how to do a filter in JavaScript? Why filter?
Well, I mean, you have to go over the data and filter out on the where clause, right? So you have to find where the data matches the where clause.
All right, cool. What did you somebody back here says?
Map.
What?
Map.
Map?
Yeah, you can, for it, you can get the data and you can get the name.
And we can get the name. Right, okay. Cool. Okay, so all right, so what I hear is that the where clause, we're going to need a filter to select only the one row that we need. And then because we're selecting only part of the data from that row, we need to do a map. Okay, so what do I actually type? Well, this is the genre table, so I'm going to start with that. And then what? Dot map. Okay.
That takes a function that receives each thing, right?
Yes, right. And the individual things here in this genre table are objects.
But I guess we don't want to map over all of them.
You want to filter.
We want to filter first.
Filter first, okay. We're playing here. This is play. This is low stakes. We're just going to try stuff and see what happens.
Row goes to row.name.
So row, now it would be row where, so row equal 6. Row dot
Row goes to
genre ID equals 6.
Yes, okay,
And then
great.
dot map
Mm-hmm.
row
Like that.
something.
I'm going to dump the result. Let's see what happens. Nothing! Okay, the reason for that actually is because I didn't mention this, but this CSV library assumes that everything's a string. So we have strings here. And we said triple equals, which is a little too strict. So we need to either relax that and let JavaScript do its terrible JavaScript thing, or we can just stick a couple quotes in there, and I think that will work. So let's try that. Oh, we got it! Yes! Yes, we got it! All right. Cool. Okay. Good, that's one down. All right, cool. So we're off to a good start. So like we learned some things here. Now we know that a where clause is a filter, and a select is a map. And we can get answers. Okay, so I'm gonna start giving these numbers. And I'll just bring this along with me down to the next example. All right, so now the query is select name from track. So different table, right? Select name from track where album ID equals 187, order by track ID. So this is selecting all of the tracks for some album, right? And then displaying their names. And order by track ID, I guess, puts them in order. I don't know. All right, so what do we need to do here? Well, we can probably start with track. Now what? Dot filter. Column ID? What?
Album ID.
Album ID. Yeah, where it's equal to 187. All right. Okay, so that filters out everything except the tracks that are actually on the album we want to look for. So far, so good. Now what?
guess we have to track IDs and names, but return only the names, right? So we need to order by the.
Who said order by? So, somebody, so what should I type? Yeah, I don't. Well, I know I just don't know what to type next. That's all. What? There is a sort function. Does anybody remember how it works in JavaScript? Like, okay, so I think sort in JavaScript is not exactly functional. It sorts the array in place, but I think we'll be okay, right? So this is a slightly non-functional function that we're using, but it just so happens we'll live. We'll be fine. All right, so this sort function, it takes two arguments, like track A and track B, and then you have to return something. Somebody remember this?
It's return which one is greater than or.
Yeah, there's like a +1, -1 thing.
-1 or 0 no change to 1.
And 1 is great. Okay, good. Yes, that's right. So yes, great. Okay. So there's not. I don't think so. Is it?
Kind of.
What is it?
A dot or locale compare is below it.
Locale compare. Okay, great. So wait a minute, but A is not a string. So what do I need to do?
So A dot track ID.
Actually, though, like order by track ID. I mean, it means numeric order, not string order. So maybe I should convert them to integers and do that. So yes, that's right. Parts in. Subtract like this. Okay. Okay, great. So actually, I'm going to get rid of the curly brace because that is not what I want. Okay, so we'll do that. And then, so now we're sorting by track ID. Okay, so that's it, right? No. Okay. What?
So you get it for each track, and you return the track.
Okay. All right. Let's see if this is actually good. So is this right? It looks about right. All right. Well, we'll give it a shot. Yes, we did it. Good work. All right. So this is REM's. I guess green is the name of the album. I don't remember the name of them.
We're having to try.
You can't read. You can't read it.
They're really
Whoa, we don't know.
we could select the IDs as well.
All right. So how do I do that? What do I change?
You have to do an object, I guess.
Oh, okay. All right.
Or no, I guess an array.
All right. All right. So all right. Pushing our luck here. It was fine, but we actually want to see if it really worked. And that looks right. We got it. How about that? This is not the actual order of the tracks on the album, but the database doesn't contain that information. So yeah, so this is right. This is great. Okay, cool. So it's working. So I'm gonna get rid of that part, and we'll do like let's do 2 more at least. Yeah, this is actually kind of an interesting one. Okay, so count star. This is a little weird. Count star like totally messes everything up. So if you know SQL, you know that like if you throw a count star into the query, then it like magically returns only 1 row instead of like how many rows it would have returned, and it returns the number of rows that were selected, right? So I was thinking about how to model this in JavaScript. This is kind of weird behavior, right? And here's what I came up with. There's actually, if you put a group by into a SQL statement, it does a similar thing, where instead of how many rows there were, now they're collected into groups of rows, right? And you get aggregate information.
Can't I just escape the Linux and do a word count -L?
Oh, right. Yeah, we should just pipe it. Well, we're going to pipe it. We are going to pipe it. We're going to do it internally to our programming language. So reduce
over the total number of rows and
that would totally do it. Yes.
do a count starting at 0.
I had something a little bit different in mind. So can anybody?
Can you just do the select like you did?
All right. So let's do that. So here, I'm not going to do this. So right. So
Plus 1.
let me see if I can. Yeah, here we go. So what am I doing here? Album is the name of the table.
Filter.
Dot filter.
Artist ID.
50 with quotes. Okay, right. So this returns an array of rows. Take the length of it, right? So just dot length, right? Okay. But what that means is, sorry?
Plus 1 though, right? The length of the array starts at 0.
But if an array has like 4 items in it, it'll return 4. So length is correct. Now this is a little different from everything else, right? You just need to know, I guess, that that when you use an aggregate function like count, or max, or min, or average, right? Then you need to do something quite different at the end than what you were doing before. And the same thing goes for group by. It's just like a really weird construct you got to get your head around. All right, let's see if this works. Actually, I don't know. Let's do it this way first. Yep, this is a bunch of U2 tracks, and then it says 10. So I think I can confirm that. I think I can check that by asking SQLite the same question. Their artist ID equals 150. Yeah, the answer is 10. Okay, great. So we did 3 queries, right? I want to do one more. I want to do this one. So what does this query do? Select album.title from album, track, where blah blah blah, order by album title. What is this doing?
Selecting from 2 different tables, right?
Yep, 2 different tables. Everybody knows the answer in the room, right? But okay. Yeah. All right. So what does SQL do when you say select stuff from 2 tables? Can somebody just tell me the answer for SQL? What does it do?
Turns every row from the table.
Returns every row from every table?
Assuming there are foreign keys involved.
Yeah, there are. So right. So you wouldn't do this unless there was a foreign key involved. So you can like make the tables actually binary, right? Okay. So what SQL actually does, if you just select everything from 2 tables and you don't mention any foreign keys and you don't use any join keyword or anything like that, what it'll do? Nope. It will just return all possible combinations of 2 tables. So it'll pick, it's like you pick one from column A, pick one from column B. It'll pick one row from table A, one row from table B, and show you those 2 tables right next to each other. So if table A has 100 items in it, and table B has 100 items in it, you'll get 10,000 results. 100 times 100. That's how SQL works. Right? That's what this is doing. So to start out to get the answer for this query, we have to begin with this combinations function that I imported. This is a really special, wonderful function that I found on the internet that I didn't look at all. But I think you just give it 2 arrays, and it does this. It returns what's called the Cartesian product of the 2. So it's an array of pairs, basically. It's an array of 1 album, 1 track for every possible combination of albums and tracks. All right, so now we just need to implement the rest of this query. And we've already, like, this is stuff we've done before. We did a where clause, we did an order by, we've done some selects. So what do I need to do next to make it go? Sorry? Filter, all right. You see a problem? Yeah, what do we have? Yeah, let me dump it. Let's see what we have. Also, maybe I'm making a mistake with the syntax, but we'll find out. The problem is this may be a lot of data, so I'm gonna like cut it down to 10 results. Is that right? I don't know the answer. I don't know the syntax. Let's find out. It didn't. It gave me nothing. Well, how about that? There we go. Okay. All right. So I did have the syntax wrong. You have to give it an array of tables, and it finds all possible combinations for those tables. And what it's giving me, what it looks like here, is that it's giving me an array of arrays, and each array, the larger array, has one album and one track. And it's giving me all possible combinations, even tracks that are not related to that album. It's giving me all the combinations. Okay. Okay.
So what's the total count for that if you weren't slicing?
Let's see. Right. So first, I'm going to ask SQLite. Right? And the answer is over 1 million. Okay? And now I'm going to ask JavaScript. And the answer is over the same number. Great. So that's good. So the combinations thing is doing what we want it to do. All right. It's printing a 10 somewhere, and yeah, gotta get rid of that. Okay. Great. So we were going to write a filter here next. So now each row in this combinations array is in fact an array with 2 objects, right? It's going to have an album object and a track object. And in fact, I can write it like this. Well, I think I need parentheses. Like that. Okay, but so what am I filtering on? What should I type here?
So you need to find where track dot album ID is the same word as album. Album.
Equals a lot of love. All right. All right. So this will already. So this will cut down a lot. I think. We'll see how many are left after that. Should not be a lot, right? 3. Okay. All right. Great, because it eliminated all of the combinations where it's a mismatch, right? Where we picked one track from one album and then a totally different album, right? This line eliminates those, right? And then it focused in on the actual track title that we want, but apparently there are several tracks with that name. Okay, but then how do we finish? What's left?
So we need to order them by the album title. So source.
Album title. Okay, so
Sort will just automatically do alphabetical strings.
we have to tell it what we want to just sort on. So we have to do this like locale compare thing, I think. So what are we sorting by? Album title? We're sorting by album title. Okay, great. So we have A0 is an album, right? Remember, both of these are pairs, right? A is a pair of things, and B is a pair of things. So A0 is an album, and dot title is that title. And then it's a locale compare like this. And then B0 dot title is the other thing we're going to compare it against. Maybe that'll work.
And then I can skip the map title of the album.
Okay, so we have a function that takes our pair of objects and produces what? Okay, all right. So again, you know, we have the select statement, and we generate this pipeline, and it's actually pretty similar, right? Like the pipeline contains a whole bunch more JavaScript-y stuff, right? Because we're telling it very precisely, like, you know, that these are objects and that it needs to use properties and indexing and all this, and you know, it has also some JavaScript-specific voodoo in it, right? That you don't. These are details you omit when you talk to SQL, right? SQL just knows how to do it, right? But it's the same sort of stuff, right? Let's see if it works. That took a little while. Okay, but yeah, it came back with Led Zeppelin 2. That was what we expected. And it turns out there's some other albums that also have a track with the same title. I'm not sure if it's the same song or not. Okay. All right, and I guess we can stop there. There's one more query in here, and I wanted to do it because it joins 3 tables together. And it turns out this combinations thing, like, we were already doing 1 million combinations, and it turns out, like, once you get to like 3 tables, we're talking about like almost 1 billion, and it actually runs out of memory on this computer. It doesn't go through. So the reason I bring that up is that actual databases do not really work by generating all possible combinations and then eliminating them. They're actually extremely clever, and when they see a where clause that has something like this in it, they find ways to eliminate work by using an index, or just, but by knowing details about how that data is arranged on disk, right? For example, they just know that like the tracks and the albums are actually stored on disk in the same order, so they can go through them both once in lockstep instead of having to generate all possible combinations, right? So, so databases have to do like a little extra work before they start reading off the disk. They have to do a little extra work by looking at the query and kind of like deciding how to avoid this combination explosion of combinations. Okay. That is a great idea. So I didn't think about it when I was preparing this, because what I wanted was something that was pretty mechanical. In other words, a pretty mechanical translation from SQL to JavaScript. The reason being, that's what we ultimately want to do, right? Like we ultimately do want to like transform SQL statements into a programming language and then run the code. And so like I didn't think of this, but yes, like if you want to go a little bit further, try implementing this by combining first the first 2 tables, filtering down as much as you can, and then then mix in the other table. And yeah, you can do it that way. There's actually there's a lot of ways you can do it. And you know, if you build functions that help you combine data.
So doesn't JavaScript have the concept of an iterator at this point?
Yeah, it does.
And couldn't you optimize similarly by building our pipeline in terms of iterators instead of arrays?
Right. So if we did that, then I wouldn't have the out-of-memory error. But I would still be doing on the order of like 1 billion array constructions and checks, right? So it would take a while. So you really do want a better algorithm, not just to avoid the memory usage, right? Yeah. Okay, so today, like the lab here is find somebody who has a laptop that you'd like to watch Red program, and discuss like what a SQL database means to you, or like what a relational database means to you. I know, like if you want to focus on just like create table, like what does it mean to like create a table and insert data into that table on disk? If you want to focus on like the idea of like having a server and people connecting to that, right, and verifying them, and then having them be able to do operations on a database. That's one thing. I want to work on select statements, so that's what I'm going to do, and that's pretty much that's all we got. So it's up to you now. Well, thanks for hanging out.
And food is here.
Oh yeah.
Yeah, so I guess the next step is